Electrochemistry. Electrochemistry is used to further our world and has a part of a lot of things we use daily, like phones, cars, computers, and etc. One of the things electrochemistry created was a battery, which is a common theme of all the things I just listed. Electrochemistry in itself is the relationship between chemical reactions and electricity. Certain chemical reactions can create electricity, while in other cases, electricity can force special chemical reactions that couldn't take place otherwise. An example of electrochemistry is this animation here. As demonstrated in the video, the chemical reaction of a galvanic cell produces energy that passes through a light bulb and has enough electricity to then power it, and then reacts with the other metal in solution on the reduction side of the galvanic cell. This is how a battery works and is what most of our current day technology uses. A question you could ask about electrochemistry, or more specifically about galvanic cells, is this: how does voltage change when using different metals and why? In the next 3 videos, the experiments conducted are all galvanic cell reactions, each using a different variable of metal and solution, and a constant metal in solution as well, along with a constant variable in the salt bridge. The way to determine whether or not a voltage changes with different reacting metals is to use a standard potential chart and test if the different voltages of the metals match with the standard potential table. The constant variables of this experiment consist of copper sulfate solution, and potassium inside of the salt bridge.
Yep. Wow, you're so good at filming.
In this experiment, I used zinc as the other metal and zinc sulfate as the other solution. The voltage shown as a voltmeter was 0.4 volts.
Voltage like move.
I can finish it tomorrow.
Try and
The
get
whole
magnesium
thing
as well.
tomorrow.
Actually,
In this experiment, I used magnesium as a change in variable and magnesium sulfate solution as a change in solution. The voltage shown was 0.1 volts. This is high on the table compared to zinc, meaning it will have a lower charge, and so far shows that different metals will have different voltages in certain experiments.
Yeah,
It is recording. Wait, let me just let it focus.
you get a bit closer.
you get numbers. How consistent it is, you've got to try and hold it on there, but that's on 200. M stands for milli. So that's 200 times 10 to the
The
negative.
changing variable in this experiment was graphite and silver nitrate as a solution. The graphite's outside layer turns into silver when mixed with silver nitrate though, meaning the metal technically labelled will be silver. The voltage of this experiment was just below 0.1 volts, so silver has the smallest voltage of them all. The reason that the different metals had different charges when replaced with another was because of their places on the standard potentials table, and where they are relative to the constant of which is Cu2 plus 2E minus. The experiment was done again if anything that could hurt the results happened, such as the mixing of the salt bridge, dirty glassware, or even a faulty voltmeter. This was done so that the experiment's results will remain as valid as it could without perfect lab conditions. Although there will be difference in results compared to perfect lab conditions. The temperature may be different, the concentration may be stronger, or even the metals differ too much in size. Because of this, the results couldn't be the exact measurement, but it is as close as you can get without perfect lab conditions. A great example of galvanic cells are batteries, and the most common one used for household items like flashlights, remotes, and phones is called a dry-cell battery, invented by Karl Glasner in the 1880s, and since then has been further improved upon by many scientists, leading to what we have today, which is a small, compact battery that is extremely durable and can deliver large amounts of energy if needed. This battery is integral to the way we use energy as a society and is relatively easy to make. They are often made with zinc and carbon or zinc and manganese dioxide. These are then placed within a liquid electrolyte, usually carbon or manganese dioxide, that is in the form of a paste. Once this has happened, they chemically react with one another and start producing electricity, all of which is then transmitted out of the dry cell battery using positive and negative electrodes. Although dry cell is efficient, many people are looking to ways to create better batteries that have almost perfect efficiency and can last significantly longer than what the dry cell can normally. One example of this is a new emerging battery nicknamed the Million Mile Battery. The reason for this name is because Tesla and Elon Musk, of whom is the creator of Tesla, are said to have created a car battery that will last over a million miles. While they are still in the process of creating and fine-tuning this battery, its impact on the world will be phenomenal, as the prices will start to become lower on electric cars, and people will stop relying heavily on coal. Another important part of this new battery is that it can be used on natural energy as well, like solar, wind, or water. The next step in battery technology will be huge. The way they've made this battery, you can tell it will last long. It's bigger than any battery before it, and uses lithium-ion battery inside of it, compared to just a lithium battery. Supposedly, it's meant to charge 5 times quicker and last even longer than the ones before it. If Tesla can finish this battery and make it available to people, it will change the way society uses electricity as a whole.